Assalamualaikum and good afternoon. I'm ZATIE ATHIRAH binti ZAIRANI. My metric number is B122310042. Today I will be presenting my final year project titled Evaluating the Impact of Panel Orientation on Solar Street Lighting System. This project is supervised by IRTS Dr. Nur Syahidah binti Muhammad Kasim. So I will start with the project introduction. This project focuses on solar street lighting by using photovoltaic energy generation. The system performance depends on panel orientation. Wrong orientation will reduce energy output and system efficiency. So PV6 is used to find out the optimal configuration under U-time condition. This slide shows objective and scope of work. For the objective, first to analyze the effect of tilt angle 0 to 30 degree and azimuth angle negative 90 to positive 90 on solar irradiance and energy output using PV6. Second, to evaluate the performance of a standalone solar street lighting system. Third, to determine the optimal orientation for maximum energy harvesting under U-time condition. For the scope of work, this project is simulation based using PV6 only. The system includes PV panel, MPPT controller, battery and LED load. The performance is evaluated based on energy output and performance ratio. We move to problem statement. The performance of solar street lighting depends on effective solar energy generation. However, in practice, panel orientation is often fixed without considering local environment condition. Most studies also focus on tilt angle with limited analysis on the combined effect of tilt and azimuth angle. This can lead to lower energy output and reduce system efficiency. Therefore, this project aim to determine the optimal tilt and azimuth angle for better energy harvesting. Background study. This slide shows the basic concept of this project. Solar irradiance is the main energy source for photovoltaic system, and energy output depends on the amounts of solar irradiance is received. Tilt angle affects how much sunlight is received, while azimuth angle determines panel direction. By optimizing both angles, the system can achieve better energy absorption and efficiency. By using PV6 is used this project to simulate and evaluate the performance system. So, this is the basic formula which that optimal tilt angle is approximately equal to location latitude. For this methodology, I use at UTM Melaka with metronome data in PV6. The system is standalone PV system of grid with PV panel, MPPT controller, battery, LED load. For your information, MPPT controller is maximum power point tracking controller. I focus on tilt angle from 0 to 30 degree and azimuth angle negative 90 to positive 90. For simulation process, I change one parameter at one time while others remain constant. Then I evaluate based on energy output and performance ratio. At the end, I compare the result to find the most optimal angle for maximum energy. So next we go to literature review. This table shows comparison of previous studies on PV system performance. Matthews et al. Consider both state and orientation and show optimal state 10 degree to 15 degree give highest energy, while Rashid et al. And Ahmad et al. Studies mainly focus on state only and found that lower state suitable for Malaysia or local latitude. But most of these studies don't consider both state and azimuth together, especially for solar street lighting. So for my project, I focus on both parameters using PVC's simulation to find out the optimal panel orientation. This slide shows the expected outcome of my project. First, I will identify optimal state and azimuth angle to maximize energy generation. Then the optimized setup is expected to improve system efficiency and performance ratio. The analysis will be based on daily and monthly average energy, so it's easier to compare. So I will compare different panel orientation. Lastly, this project aims to develop a reliable and practical PV system designed for solar street lighting. We go to project outcome. First, I determine optimal state and azimuth angle for maximum energy. This helps improve energy output and overall performance of standalone PV street lighting. It also enhances system efficiency through better panel orientation. At the same time, it supports sustainable and renewable energy application. Last but not least, this project can be practical reference for PV system design, especially in tropical region like Malaysia. This slide shows the project timeline using Gantt chart. For semester 1, I start with literature review on solar PV system and proposal writing. Then continue with data collection and data analysis. After that, I proceed with initial simulation using PVCs. Moving to semester 2, I focus on performance evaluation and parameter optimization. Then I validate the result and develop the final design. Finally, I complete the project with thesis submission and presentation. In this conclusion, panel orientation is big impact on solar street lighting performance. Both state and azimuth angle affect energy generation and system efficiency. The simulation result help to clearly compare different configuration. PVCs also proved to be a reliable tool for PV system analysis. Overall, this project provides a practical reference for optimizing solar panel installation in real world. I think I need to be clarified why I'm using 90 degrees. I'm use negative 90 to positive 90 degrees sebab nak cover from east to west direction which follow sun movement. Beyond that, tak practical because panel tak menghadap matahari. The second one is why state angle 0 to 30 degrees. Malaysia dekat with Khatulistiwa, so that state angle usually low in 0 to 30 degree. Thank you from me.